Welcome to Wisdom Study. In this chapter, we will study about net present value. Net present value based on time value of money, chapter 6. Let's see. Net present value is actually the value difference between the cash outflows and cash inflows at the base period. Let's see the concept behind the NPV. NPV is used in the context of capital budgeting. Capital budgeting in general implies huge capital expenditure incurred by business organizations to set up a project and to find out project is acceptable, project is viable or not. NPV is used. One point is to be mentioned here that if NPV is greater than or equal to 0, then project is acceptable or project is viable, and less than 0, then project is not acceptable. There NPV is used. Capital expenditure being long-term investment has long-term loan implications and is exposed to many uncertainties, hence high risk. The financial appraisal of such projects is done by using discounting techniques that includes NPV and IRR. NPV can be calculated by using very simple formula. NPV is equal to C1 plus C2 plus C3, C4 and so on. And this all sum will be subtracted from initial investment. Okay, where C0 is initial investment, C1 C2 represents present value of first year, second year respectively, and so on. Point to remember, as I said, NPV is when NPV is greater than or equal to 0, project is acceptable, and when NPV is less than 0, project is not acceptable. Let's see one example. Suppose the cost of any project is 2 lakh and cash flow for following years are as year 1, year 2, year 3. This 1 lakh, 1,50,000, 1,75,000, and if discount rate is 10%, calculate NPV. It is very easy. We know NPV is equal to C1 plus C2 plus C3 up to S1 C up to Cn, and in last minus CO, where C0 is initial investment and C1 C2 represents present cash flow, sorry, present value of first years and second years and so on respectively. Here we have been given initial cash flow, that is initial investment is 2 lakh, and discount rate is 10%. Okay, by putting them respectively on their respective fields, we get just see here how this is calculated here. Okay, by putting all respective values on respective fields, we get NPV is equal to 1,46,225.12. Here 0.12 is missing here, do not worry about that. Here we get NPV is equal to 1,46,225. Okay, this is also calculated using present value of annuity factor. Okay, we will see in next case study how it is done, but this is very simple. You don't have to see all those annuity factor value here. Using your calculator you can solve it easily. Okay, here we see NPV is greater than 0, hence this project is acceptable. Let's see another case study. In case study 1, if the discount rate is 10%, okay, and initial investment is 5,000, and cash flows are for 5 years are written here: 1,000, 1,200, 1,600, 2,000, 1,800. Okay, total cash flows are given here, and if discount factor is 10%, then And this is the present value annuity factor. Okay, for 10%, for first year, for second year, for third year, for fourth year, for fifth year, and by multiplying we get this, and after subtracting, this is the initial investment, this is the total sum of all the cash flows, we get 585, that is positive NPV, that means greater than 0. So this project is acceptable. This is the same problem based on the first example that we saw just earlier. This can be solved the same way, but here discount factor of 10% is given here, and using the present value of annuity factor we can get it easily. Okay, in case study second, it, problem is same. Okay, cash flow initial investment is 5,000 and cash flows are similar to the first case study, similar to the first case study, 1,000, 1,200, 1,600, 2,000 and 1,800. Okay, here the initial investments is 5,000 and discount rate is 15%. Here, after calculating, we get NPV is equal to minus 132, which is less than 0. Here, net present value is minus 132 at 15% discount rate. So, our decision should be investment cannot be made. That means that project is not viable. Okay, this project will return negative NPV. NPV is equal to cash flow divided by 1 plus discount rate upon n, where n is equal to number of cash flows minus initial investment. Okay, this is also one of the formula. Okay, in next videos we will study about sampling method and will solve numerical on sampling in details with discussions. If you are new to this chapter that we discussed in this video, you are requested to see all the videos previously uploaded on time value of money. The detailed numerical on annuities have been discussed in 5 parts. Part 1, Part 2, Part 3, Part 4, Part 5. The links of all previous parts are given on description section. Okay, please give your suggestion on comment section. Thank you.